Hey everyone, it's Justin again. In this lesson, we're going to be exploring the relationship between perpendicular lines and distance to find the shortest possible path between a point and a line. By the end of this lesson, you will be able to find the shortest distance between a point and a line. First, we'll discuss desire paths. Next, we'll explore the shortest distance between lines and points. Finally, we'll complete 2 practice problems. Have you ever seen a desire path? A desire path is what it's called when people wear down the ground by walking consistently along a line that's not part of a man-made path. This usually happens when the sidewalks aren't planned to allow people to follow the shortest possible path to their destination. Whenever I see desire paths, I always find myself thinking, if only that city planner had used perpendicular lines to calculate the shortest distance. You probably know that the shortest distance between 2 points will always be a straight line. But what about the shortest distance between a point and a line? For example, take line M here and point A. I can make infinitely many straight lines between line M and point A. So how do I know which one of those is the shortest? Here are just a few of the line segments that go from line M to point A. Which of these line segments looks like the shortest? Line segment EA is definitely the shortest here. Do you notice anything about the relationship between line M and line segment EA? They're perpendicular. We can tell because they meet in a right angle. But it can be hard to identify when an angle is exactly 90 degrees. The best way to tell that they're perpendicular is to look at their slopes. Take a look at the provided graph. What's the slope of line M? We can see that between each point, the rise is -3 and the run is +1. That makes a slope of -3. What about the slope of segment EA? We can see that between each point, the rise is +1 and the run is +3. That makes a slope of +1/3. Are those two slopes opposite reciprocals? Yes. So line M and segment EA are definitely perpendicular. This will always be true. The shortest distance between a point and a line will always be the length of the perpendicular segment between them. Let's apply this new knowledge to a practice problem. Find the distance between line BU and point N. We can always assume that when asked for a distance, it means the shortest possible distance. Let's bring that new fact back in here. The shortest distance between a line and a point will always be the length of the perpendicular line between them. So we need to find the perpendicular line from line BU and point N. What do we know about finding lines that are perpendicular to given lines? Their slopes should be opposite reciprocals. So let's see, what's the slope of line BU? The slope of line BU is +1/2. So what would be the slope that's perpendicular to that? Flip it over, take the opposite sign, and we get -2. Okay, so I need a line with a slope of -2 to go from line BU to point N. I don't know where that's going to land on line BU, but I know that point N has to be on it. Let's start at point N and follow our rise of -2 and our run of +1 to find the next point. We'll just keep going until we hit line BU. And here's our intersection. Let's call this intersection point Y. You don't need to name any points that you add to your diagram, but in our case, it's going to help us be able to talk about it more easily. Now that we've found the line segment that represents the shortest distance between our line and our point, we need to find the distance that it represents. How can I find the distance between point N and point Y? The distance formula. Let's see. Point N is negative 2 comma 3, and point Y is 1 comma negative 3. Remember, we can label these points either way, and we'll still get our correct answer. So pause the video here and find the distance between point N and point Y. Let's check your work. I'm going to make point N x2, y2 and point Y x1, y1. If you labeled them the opposite way, our work will look a little different, but we should get the same answer. Next, I'll substitute my points into the distance formula. Then I will simplify. Now that I have the distance, the square root of 45, I need to check to make sure that this is fully simplified. In this case, there's more than I can simplify, because 45 is 9 times 5. Since this is a measure of distance, I should include the label of units in my final answer. Pause the video here and take a moment to summarize this process in your notes template PDF before moving on to the next example problem. Let's do one more example together. This problem tells us to find the distance between line WA and point G. What do you think would be a good first step in this problem? Since we know the shortest distance will be along a line perpendicular to line WA, let's find that perpendicular slope first. Go ahead and do that now. Since line WA has a slope of negative 2 over 3, the perpendicular slope would be positive 3 over 2. Now that I have the perpendicular slope, what can I do with it? Yes, I can use my perpendicular rise and run to work from point G and find the intersection point on line WA. Take a moment to find that intersection point now. Did you figure out that the intersection is here at 3 comma negative 3? Let's call that point B just to make it easier to refer to. So the distance between line WA and point G will be the distance between point B and point G. What should we do to find the distance between these 2 points? Did you say we should use the distance formula? Nice job. Pause the video here and solve for your final answer. I used point G as x1, y1, but if you had it labeled as x2, y2, we should still get the same answer. From here, I substituted into my distance formula and simplified as much as possible. We get that the distance is the square root of 52. Can I simplify that square root? Yes. 52 is 4 times 13, so this can and should be rewritten as 2 root 13. But wait! Before we can say this is our final answer, we need to add units, since this is a distance. That was our final example for this lesson. Now you know how to find the shortest distance between a line and a point using your new skills from throughout this unit. See you next time!